I won't be here for the discussion section in week one. However, Rodrigo Martinez, your TA that you've met on Friday of week 0, will be here. Rodrigo has a bachelor's degree in aerospace engineering, and he'll be able to help you through some of these things that you need to do. However, most of what you need to do is on you. I've provided these little videos, and you should look at these all ahead of time so that you're familiar with what the requirements for the week 1 experiments are, and you should make sure and have read the requirements ahead of time also, because there's not a lot of time. We only have 50 minutes to get through 3 experiments, and those three experiments, when you get to the end, you need to actually develop some formulas that will predict what it is we're going to see. When you come into class, Rodrigo should have laid out 2 scales for you, a 2x beam, and notice these 2x beams were just hand cut. They have some foibles, so everybody won't have exactly the same numbers in class, and that's the way it is in real life. Rodrigo should also have provided each table with 5 bricks. Make sure that you don't accidentally pick up any concrete bricks. You should have learned the difference between red clay bricks and concrete bricks in 341 last year. The first thing that you need to do is make sure you brought a pad of paper to be able to write on, that you brought something to be able to measure with. You can either measure with an architect scale or an engineering scale, or measure with a tape measure. You should measure how long your beam is, and every beam is going to be a little bit different because again, I just cut them by eye. I didn't actually measure them. They're close, but not all exactly the same. And you should zero out each scale. And the way that you zero out the scales is on the very back. You'll see a little knob here. And all you have to do is twist that knob looking directly at the scale and get it to 0. Get each one down to 0, and we'll do it with this one over here also. I'll get it down to 0. Turn it one way if it's on the big numbers on the scale. You turn it another way if it's on the little numbers on the scale. First thing you want to do is set your beam onto the scale for experiment 1, and actually make sure that the beam is right in the center of the plate, and just lean down and look at it from behind. You'll be able to see where the exact center is. Then you want to come around and measure on the scale, and make sure you do the measurements in pounds. The dimensions you can do either in feet or in inches. Doesn't really make any difference. In real structures, we actually use feet as opposed to inches most of the time. The scale on your left is reaction 1. The scale on your right is reaction 2. And I've listed a reaction 1 here and a reaction 2 here with the weight of the beam. And we have 2.25 pounds, 2.25 pounds lb, and 1.75 pounds on reaction 2. Now, what are some of the reasons why it's not exactly the same? You would think it would be exactly the same, but this particular beam that I chose, and somebody's going to end up with this beam, it has a whole bunch hacked off of it. So it's actually heavier on this end than it is on the other end. And what we're going to want to do is, once we've recorded that, we're going to want to actually sit back now and re-zero our scales. So we come to the very front again and look directly at the center of the dial and re-zero it. We're getting rid of the self-weight of the scale. We'll add that self-weight back in at some other time. We want to figure out where the exact center of our particular beam is here, and we need 18 1/8 inches because this is 36.6, 18, 36, 37, 38, 39, 40, 41, 42 1/8. So we need 21, which is 12, 18, 19, 20, 21 1/8. So that's the center of the beam there. You can put a little tiny mark that's not going to be a big mark, and simply set your brick directly in the center. It doesn't make any difference whether you set your brick down this way or whether you set your brick down this way. It should give you the same reading as long as you've actually put it into the center. And again, we would record R1 in this particular case is 2.5 pounds, 2.5 pounds for R1 and 2.25 pounds for R2. Why is it different? Well, some of these bricks weigh a little more than others. The average weight should be right around 5 pounds, but if you look at some of the bricks, there's some nicks and things taken off of them, not to worry about those. Just go ahead and use the bricks that Rodrigo sets out for you. We should also know what this dimension is here and this dimension is. This dimension is A, this dimension is B, and it's divided right in half. So whatever it was, I forget what it was, you should make sure and record what that half dimension is also. Hopefully you can get to that point and have that information actually all written down.